would be new. But all this is purely just getting you guys familiar with these numbers. If you know your squares through 10, you know your cubes through 5, then you don't need to do those, okay? But if you're not, that familiar with, what the square root of 169 is, then that's what this is here for, okay? There's nothing tricky about these. They just go in order, but it's just about getting you guys familiar with these numbers, okay? The cube root of, 1,000 is 10. The cube root of 729 is 9. The cube root of 512 is 8, okay? So it would behoove you guys to spend some time, writing out these lists, or print off the lists and get it down. I know obviously if you have to write it out by hand, it's going to take you a while. Okay, but you guys will be able to use this on your quiz. You guys will be using it on homework. We'll be using it today during the lesson. Okay, what is the fourth root of 1? Well, of course, it's 1. What's the fourth root of 16? So just starting to get comfortable with some of these numbers. Okay, we'll talk about how we're going to use this later, but just want you guys to see that you have it. If you need to print it off, or if you need to just fill it out, again, focus on the ones that you don't know. Okay, if you know the cube root of 64 is 4, don't worry about it. And it's the ones that you don't know that I want you guys to focus on. All right. Again, I would really suggest that you get that printed out or written out. We are here. All right, we're going to do this today. Actually, we really did this part yesterday, so this doesn't need to be there. We looked at other roots yesterday. So really what we're doing today is looking at rational exponents. Okay. I want to start off with just kind of trying to help you guys remember that, when you first saw exponents, or as we first seen different types of exponents, the confusion that was there, and then just how we built that understanding of exponents. So, what misconceptions were part of there, and then what's the reality of those. So we can build towards rational exponents. Rational exponents are fractional exponents. So when we look at 9 to the 1/2, what does that mean? Okay. So that's what we're pushing towards today, is looking at fractional rational exponents. What do those do? How do we use them? How do we manipulate them? Things like that. Okay. That's where we're moving towards. So if you think back to way back when you first saw an exponent, right? The very first time you saw an exponent, you saw 9 to the second. What could you probably thought that meant, right? Maybe you just thought it meant 9 times 2, okay? Which would, of course, be 18. But of course, that's not what 9 squared means. It means 9 times 9, which is 81. Okay. Most common misconception with 9 to the 0 power is that 9 to the 0 power is equal to 0. But 9 to the 0 power is actually equal to what? Yep.
1.
1, yep. Anything to 0 power is 1. Okay. Most common misconception with negative exponents is that people just think it's the negative of 9 squared, which would be negative 81. But negative exponents actually are what? Division, right? Fractions, right? 1 over 9 squared is what that means, right? Or 1 over 81, right, Aiden? Okay. So negative exponents don't mean negative numbers, they mean fractions, right? And so then, you see 9 to the 1/2. Oh, what's 9 to the 1/2 mean? Oh, maybe it just means 9 times 1/2, right? Which would be 4.5. But 9 to the 1/2 doesn't give us 4.5, right? What do we get when we take 9 to the 1/2? So I just want to go to the calculator real quick and see what happens. You do need to be really careful about how you type this into a calculator. So I hit 9 and then do my caret. You need to use parentheses. The calculator needs to know that 1/2 is grouped together, okay, that it's all together. So when I do that, when I hit enter, it's going to go and redisplay it. It's a little weird because of the way they did the parentheses there, like how the parentheses are just on the bottom for some reason. I think it's just a display issue. Okay, but you notice that it is pushed up into the exponent spot. Okay, and it says 9 to the 1/2 is equal to 3. If I'm not careful in the way I type it, so 9 to the, and then I don't use parentheses, okay, it'll give me the wrong answer. That's on me. Okay? And then when it goes to display it, you can see that it's not displaying correctly at all. So, you see what it's doing is taking 9 to the first power and then dividing that by 2. Okay? So it is really important that if you go to type rational exponents into a calculator, make sure you put parentheses around them as you do that. Okay? But we can see that 9 to the 1/2 gives us 3. Okay? So I want to talk about why that is. All right? So it's definitely not 4.5. It's 3. Okay? So misconception versus reality. Right? It's not just half of the number. Let's get that right out of our heads. Okay? We're going to talk about how to do that here in a second. Does anybody need more time here with this page? For some reason you didn't take the quiz last Friday, or last Thursday, really make sure you guys get that done tomorrow during the flex time. We'll have a test makeup block set up like an hour, 2 of the sessions in a row, so it'll be a little bit over an hour. I think it'll be the 3rd and 4th session, so make sure. I know there's still quite a few people that haven't taken the quiz, so okay. This is going to be a really important page as far as your notes for this topic. Okay, so there in the top left there, I'm saying know this. Okay, these 3 things here. These are essentially like vocab that you need to know in order to do the other stuff we're going to do. In order for us to be able to figure out what x to the 2/3 is, we have to know what x to the 1/3 is. Okay? If I want to be able to figure out what x to the 5/4 is, I have to know what x to the 1/4 is. Okay, so these are going to be kind of our building block pieces here that we're going to be able to use to then turn into other things or manipulate to understand other problems. Okay? So this is almost like when I said, hey, you need to know that the square root of -1 is equal to I. That's just straight up definition. You need to know it. So if you don't know that, then it's really hard to do stuff with I, talk about I. Okay? So you guys need to know these. Just straight up vocabulary. What's x to the 1/2 mean? Boom, spit it out. What's x to 1/3 mean? Boom, spit it out. Okay? So what does it mean, right? And Mason, you're right. Aiden, you're right. It's just a square root. Okay? X to the 1/2 is the square root of x. So x to the 1/2 means the square root of x. X to the 1/3, in a very similar way, means the cube root of x. And again, in a similar way, x to the 1/4 means the 4th root of x. So that is the definition of those terms. That is what they mean. I also want you guys to hear me say that over and over again. Okay? X to the 1/2, or I could say x to the 1/2 power. So x to the 1/2. X to the 1/2 power is the square root of x. X to the 1/3, or x to the 1/3 power, is the cube root of x, or the 3rd root of x. X to the 1/4, or x to the 1/4 power, is the 4th root of x. Okay? So I'm saying I'm talking about exponents, and I say 4th root of x, right? Cube root of x, square root of x. Okay? So how does that work? How do we take those and manipulate them, if that's what those are defined as? How do we take those and manipulate those to be able to talk about 2/3 or 5/4? Okay? So all I've done there is rewrite. Okay? So I rewrote that from the exponent form. So I started off with into the radical form. So this is the exponent form. This is the radical form. Okay? Those things are equal to each other. There's different ways of writing the same thing. Okay? And then down here we're going to go backwards. If I give you the radical form, I'm going to give you the exponent form. So if I gave you this, how would you spit this out? Okay? So how do we go from here to here? So it's just rewriting, okay? Which really means the x. We can see the x moved over. Yeah, but where did the numbers go? Okay, so where did they go? Well, it's more obvious with the 3 and the 4, where the 3 and the 4 went. The denominator of my exponent became the index of my radical. Remember that number is called the index there. The denominator of the exponent became the index of the radical. We see that here with the 4 also. Okay? The 4 became our index. Well, why don't we see our 2, right? Remember, we don't write a 2 there. There is a 2 there, but we don't write it because that's the square root. There's nothing more basic than a square root. There's no 1th root. We don't write the most basic one down. We just assume it. That's a square root. So we don't write the 2, but it's there. Okay? So we see where the 2, the 3, and the 4 went. They're in the index spot. The denominators are now the indexes. Where did the 1s go? Now the 1s are all right here. Right? X to the first, x to the first, x to the first. Right? And in the same way that we don't write that 2 there on a square root, we don't write a 1 on the x to the first. Okay? So the numerator of the exponent became the power, or the exponent of the base. Okay? The denominator of the exponent became the index. The numerator became the exponent, or the power. The denominator became the index. The numerator became the power. The denominator became the index. So as I go to rewrite this, x to the 2/3, into radical form, I'm going to follow that same pattern. So I know I need an x and I know I need a radical. Okay? Because I'm getting into radical form. So I just need my base and I need my radical. And then from there I can fill in the kind of the stuff that's going to be around it. I'm going to start with that. I always like to start with the index, okay, because it's there in the front of the problem. I need to know what that is. The index always comes from the denominator. So this would be a cube root of x. Okay. Then I go to the numerator, which is the power of the problem. So that's going to be x squared. So how I say this, x to the 2/3, okay, equals the cube root of x squared. Okay, let me say it again. X to the 2/3 power equals the cube root of x squared. Now there is a different way to write this in radical form, which I prefer when we're doing evaluating, which is something that we're going to do later. Right now we're just doing rewriting, and I probably would rewrite it the first way if we were stopping there. Yeah. But if it's an evaluation problem where I actually want something like back out of it, like I want to know what the answer is, I prefer this style of rewriting. So the cube root of x, that didn't change. What changes is where I put the 2. Okay. Those two things are, okay, they mean the same thing. Actually, all three things mean the same thing. They're just different ways of writing it. Okay. But these two are very, very, they're both radical form. Okay. Again, I prefer the second form there when we're doing evaluation. So generally, that's the way I like to write it, just period. Usually, when you see stuff typed out, it'll look like this. This is the least amount of typing. So that's usually the way it gets typed out. But again, I think this is the most useful form. So generally, when I write it, I will write it this way. Okay. So I'll look at the next one, x to the 5/4. I need a radical. I need an x. And I say, hey, what's my index? Where do I find my index? My index is always my denominator. So my index is a 4, so that's a 4th root. Now I need my power. Where's that? X, the numerator go? That goes onto the 5. Or it goes on the x there. So we got the 4th root of x to the 5th. Not super happy about how I wrote that. Oops. Just don't like how big I wrote everything. It was so tiny. So the 4th root of x to the 5th is how I would say that. X to the 5/4 power is equal to the 4th root of x to the 5th. Again, if I want to write it in the other form, it would be the 4th root of x to the 5th. And I'll show you when we go to do the next stuff why I like that one better than the other one. Okay, and you'll probably agree with me. So that's going from exponent form to radical form. Okay, here we're going to go backwards from that. Okay? Now it's in radical form. I'm going to go back to exponent form. So if I have this, how do I get back to here? If I have this, how do I get back to here? So definitely the easiest thing to pay attention to is just what the base is, right? So we have an x there, so I need an x back, and we just need to figure out what the exponent is going to be. Okay. Again, I like to start with the index because it's right there in the front. So where's that 5 go? Okay. Oops. The index is always the denominator of the exponent. So that's a 5 on the bottom. Then I look at that power. There's a 2 there. So it'd be a 2/5. That's x to the 2/5. What I want you guys to be really careful about doing here is your handwriting. Okay, Mr. Wildman. All right, this is not okay. That does not look at all like an exponent. Okay? So you guys are not allowed to do that. It needs to be small. It needs to be up on the right corner there. Right, if you need to make your x really big so that you can, write your exponent legibly, then you need to do that. Okay, so if you need to write bigger so that your handwriting is legible, then do that. X to the 2/5. You'll notice that when I type them, they come out like where the exponents or the fractions will come out as a line rather than stacked. Okay, just over the years I've seen too many students get confused if I say something like 9. And then the exponent's kind of stacked here. It looks too close to this. It's too close. Whereas if it's like this, as far as the typing goes, it's pretty clear that that's just the exponent. Okay, so this is what we're trying to avoid, how similar those are. Okay, whereas this is very clear. What's this last problem here telling us but not telling us? What's it not saying but we need to pay attention to? Right, Courtney, the 2, right? So there's that 2 right here that we just don't talk about. Yeah, it's there though. And so we just need to attend to that when we write the problem. So we know there's an x. Right? We know there's going to be a little fraction up here. So then we say, hey, there's a 2 right there. So that 2 goes there. Right? And then we say, hey, there's a 3 over here. Right? So we're going to deal with that 3. So x to the 3/2 power. So the square root of x cubed is equal to x to the 3/2. Write it so it's clear. Right? This is clearer to me than this is. Okay? And the other one. This is a really important page, like, as far as just getting this down, being able to move between the 2 forms fluidly. It's going to be really important for what we're going to do next. Okay? And then again, that you guys have, these things. Just again, it's going to be vocab. You just need to know those. Yeah, a blank index is a 2, Jarrett, right? A blank index is a 2. A blank power is a what? Right? A blank power is a 1. Remember, it's a 2 because that's the square root. Usually when students mess this up, they start putting 1s here, right? And I say, well, read that. Read this to me. What's it say? Square root of x. What's the first word you said? Square. What's square mean? 2. Oh, yeah. Right? So it's a square root. There's no such thing as a 1th root. Okay? We're going to go apply this. So are you guys good to move on? All right. I know on the worksheet I wrote the instructions just slightly differently. It says rewrite into radical form, then evaluate. So, okay. The last thing we were doing was simplifying. Okay. Of course, we didn't have any values anyways because everything was about an x. But here we're actually going to get an answer out of this. Okay. When we're done, we're going to have a number answer. Okay. Evaluate means a number. That's it. Okay, so our very final thing will be a value. We're going to do that without using a calculator though. Okay, so how do we figure out what 27 to the 2/3 is? Okay, so the first thing I want to do is turn that into a radical. So I know I need a 27, and I know I need a radical. Okay, that stuff has to be there. And then my job is to figure out where the other things go. Okay, where's that 3 go? Where's that 2 go? Okay. The denominator is always the index. The numerator is always the power. So I want the cube root of 27 squared. Cube root of 27 squared. Okay. So I'm going to say that again. 27 to the 2/3. 27 to the 2/3 power equals the cube root of 27 squared. Okay. I told you guys that I prefer the other form more. Cube root of 27 squared. I prefer that form. And I'm going to tell you why right now. Okay. When you're evaluating, you should be following order of operations. Okay. If we follow order of operations here, we would need to take 27 and square it first. I don't know what 27 squared is, but I know it's a big number. Okay. And then I'd have to try to figure out what the cube root of 27 squared is. I have no idea what that is. Okay. If I do this method and I follow order of operations, I have to do what's inside the parentheses first. Cube root of 27. Oh, I know what that is. Or it's pretty easy to figure out. Or it's on my chart. Okay. Cube root of 27. And then I take that number, which I know, and it's a small number, and I square it. Okay. So this allows me to shrink the problem, then make it bigger, versus make the problem huge, and then try to shrink it. Okay. So you guys see the advantage of writing it this way when I need to evaluate. Because I need to make the number small and then make it big, versus making it huge and then try to shrink it. Okay. So when I do that, cube root of 27, if you don't know it, you need to flip back to your chart. That's not what I wanted to do. Duplicate. There in the middle, cube root 27. Cube root 27 is 3. Okay. Cube root 27 is 3. So that's equal to 3 squared, which of course is 9. So what I'm going to want to see from you guys as far as work and stuff is all of this. Okay. I'm not going to be happy if you get right on the problem and then you give me an answer. Okay. You need to rewrite it into radical form and then show me how it's changing. Okay. I want to see all 3 steps. Okay. That's my expectation here. I'm not going to do this anymore because it's not useful. I'm going to go straight to the other form. So I'm going to do it again. 625 to the 3/4 power. I need a radical. I need my 625. Then I stop and I think, all right, where does my 4 go? Where does my 3 go? Okay. The denominator always goes on the index. And I'm going to put those parentheses there now. My numerator always goes as the power there. So I need to figure out what's inside of there now. Right? I need to figure out what the 4th root of 625 is. Go back to the chart. 4th root, that's over here on the right. 4th root of 625 is 5. So 5 cubed. If you need a calculator now, that's fine. If you need to take 5 times 5 times 5 in a calculator, that's fine. You can go back to the chart and also figure that out. Okay. There will be some numbers on here that won't be on your chart, like those 2 that I'm having you guys do are going to get really big. So I don't mind if you use a calculator right here to figure that out. Okay. I do not want you plugging this into a calculator and getting an answer. I do not want you plugging this into a calculator and getting an answer. I want using your chart, trying to figure out it a different way. Okay, but if you need to do that multiplication right there, that's fine. Okay. But again, these are the steps I want to see from you guys. Last one to do with you, then I'll have you guys do 2 on your own. So the 81 to the 3 halves. So 81, and then I need a radical. So always starting there. Then I need to figure out where's my 2 going, where's my 3 going. Okay. The 2 is the index. I'm not going to write a 2 there. I can write a 2 there, but I'm not going to do that. Okay, that doesn't feel right. And then the 3 is my power. Okay. I don't like writing the 2 on the square roots. Okay. I know what the square root of 81 is. I don't need a chart for that. That's 9. All right. And if I need to use my chart to figure out what 9 cubed is, I certainly can. How you would do that? Dang it. So you use that cube column, go to where the 9 is, and just go this way. Okay. Instead of going from left to the right, go to the right to the left. So 9 cubed must be 729. Okay. Anything you guys want to explain there? Are you ready to do the 2 that I've got? Again, because of the numbers I gave you guys, feel free to use a calculator at this spot, okay, where you're doing this part. Okay. Especially since I gave you this 5 here. But both of the answers are pretty big, so like in the thousands. And just send me what you got in the chat. All right. That's what you should be getting. What's going wrong there, Braylon? You saying in particular on number either, Braylon, that's going wrong? Okay. Samantha, just FYI, this is new to everybody, so you're not behind on any of that. So anything you guys want to talk about here? We're gonna move on to the next piece of stuff that'll be different than this, but anything I want to clarify here? Okay. So the next kind of side of this is just dealing with like the properties of the exponents in regards to these rational exponents. So on the last quiz you guys took, properties of exponents was something we did. What when it says multiply, what do we do? When it says divide, what do we do? We take a power to a power, what do we do? What do negative exponents do? What do zero exponents do? That type of stuff. Okay. So we're just applying those properties to these now fractional exponents, rational exponents. I'm asking you guys to simplify. Okay, you're leaving your answers with positive exponents only. You are not going to evaluate. Okay. We were just evaluating. You were getting an answer that was just a number. That was it. Okay. We are not going to do that. Your answers will have exponents in them. Okay. Do not evaluate. Sometimes it's easier if you take a step back, and so you see this problem that says 8 to the negative 2/3, and it can get overwhelming. You're like, negatives and fractions, right? Your brain explodes. Okay. So you take a step back and say, well, how do I deal with just negatives, right? What's 8 to the negative 2, right? Let's take away one layer of the onion here, right? Let's just get rid of the fraction part and just think about the negative part. How do I deal with that? Oh, okay, that was just 1 over 8 squared. Right? And we're not going to evaluate it, so I'm not going to say it's 1 over 64. It's just 1 over 8 squared. So how do I deal with 8 to the negative 2/3? Well, what do negative exponents want to do? They want to become fractions. So it's 1 over 8 to the 2/3. So again, you got to watch your handwriting here. Right? I got a fraction and I got a fraction. So I got to make sure that I can actually see what I'm talking about here. That I'm writing big enough so it's not all like squished. All right, I have no idea what that says. Okay, because I'm trying to write too small. There's more that we could do. We're not going to do that right now. Okay, this is all we're going to do right now. It's just work on the negative. Let's drop it down. Boom, that's it. I think the main mistake I see people make with this, they say, oh, negatives, that means I flip it. And they give me back this. Okay? The whole thing drops to the bottom, becomes positive. Exponent now. Okay? That's all we're doing right now. 256 to the negative 1/4. 1 over the whole thing, drop to the bottom. Positive exponent now. 1 over 256 to the 1/4. That's it. That's all we're doing. Okay? See, y to the 1/4 times y to the 2/3. Let's take a step back, right? How did we do x squared times x cubed? How do we do that?
Would you simplify those by themselves and then combine them afterwards?
All right, answer the question I'm asking, Aiden. How do we do this?
Oh, right there. Oh, you add the exponents.
Add the exponents, right?
Sorry, I was looking at the actual question.
Okay, so when it said multiply, as long as the bases are the same, we just add the exponents. So multiplying, the bases are the same, we're going to add the exponents. So what's that mean, right? So that means y to the 1/4 plus 2/3. Okay, now we need to do that math, all right? And this is obviously more difficult than just adding 2 plus 3, okay? So usually what I'll do in situations like this where I have, a little bit more complex arithmetic to do, it's not really part of the problem per se, it's something I need to do to get the problem done, but it's not really part of the problem. I'll take that and I'll move it off to the side. I say, okay, well, how do I do 1/4 plus 2/3? Okay, and we want to add fractions, we need to have what?
Common denominator.
Yeah, common denominators. So I need the denominators to be the same in order to add them. It's just essentially like terms, okay? I can't add thirds and fourths, but I can add 12ths to 12ths. So if I can make them both 12, right, then they'd be the same. Well, if I multiply the bottom by 4, I've got to multiply the top by 4. If I multiply the bottom by 3, I've got to multiply the top by 3. So I'm really looking at here is 3/12 plus 8/12. 3/12 plus 8/12 is 11/12. So now I've got my answer there. That's equal to y to the 11/12. Again, not y to 11/12, right? Not like that. Okay. I would like to see all of that from you guys there. Right? What are you doing and what do you get? If not, you're also showing me this too, showing me how you did it. Yeah, I'm hoping some of you guys can add fractions pretty well. Every year, it's always a struggle for some people. Okay, but at the very least, I want you to show me like what your intention is. I should be adding these two fractions. Here's what I got. Okay, if you're not also showing me your fraction work off to the side, but at the very least, I want to see those two steps. So I'm going to look at 3 to the 1/4 times 3 to the 7/4. So it says multiply, so I'm going to add my exponents. I'm going to take that math that I need to do and bring it off to the side. Now you're going to come over here or something like that. No, I meant to do this earlier, sorry. Of course, 1/4 plus 7/4. Thankfully, we already have common denominators, so you don't have to worry about that. That's equal to 8/4. Well, 8 divided by 4 is 2. So since I could reduce that fraction, I did. Okay. Remember, we are simplifying. So 3 to the 1/4 plus 7/4, this is the same as 3 to the 2nd. We are not evaluating, so I don't want you to tell me that's 9. Okay. So there's what I want to see back from you guys at least.
Mr. Baker, I have a question.
So, Jared.
So, say it was like 3/4 and 1/2.
Mhm.
Can I just like do the make the denominator equal on one side? So, like I wanted to get it both to 4, but one's already at 4. Can I just like multiply one side of it?
Of course.
We're gonna do both sides. Okay.
They just need to be the same. It doesn't matter how you get them there.
All right. Thank you.
Yep. So multiply that by 2, multiply that by 2. So you'd have 2/4 plus 3/4, which of course is 5/4. So equals 5 to the 5/4 power. You do not do mixed numbers. This is actually a good thing you bring up, Jerry. You do not do mixed numbers when you're doing exponents, right? It's not 5 to the 1 and 1/4 power. We do not do that. Okay? You do not do decimal powers. They're fractions or they're improper fractions. That's it. Okay? Not okay to do that. Improper fractions are fine. We saw that earlier. Okay? We know how to, if we wanted to evaluate that as an improper fraction, we could. That would be the 4th root of 5 to the 5th power. We can figure that out. Okay? So again, that's not what we're doing right now, but we can deal with improper fractions. Do not turn it into a mixed number. All right, so we're not going to get to the next thing, which is fine. I just want to show you what we're going to talk about. Powers of powers. You guys should know how to deal with powers of powers. Right, we've talked about that. Now they're just fractions, so it just adds a little layer of messiness to it. And then division. You guys, again, should know how to deal with division. We've talked about that. And just adding the fractions there makes it a little messy. So technically, you guys should be able to do the homework. Okay, but on Thursday, we're going to come back, finish this up, and I'm going to give you guys time to work on things. Okay, so Thursday should be a pretty easy day. Okay. Be that as it is, so, in regards to your homework, so you guys have this worksheet here. So, 1 through 3 there, rewriting. You should be able to do that. 4 through 6, rewriting. You should be able to do that. 7 through 10 there, rewriting and then evaluating. That's where you're using your chart. You should be able to do that. Okay. Now 11 through 20, we've done some of them. We haven't done others. 11, multiplication. We talked about that. You should be able to do that. 12, we haven't talked about it because it's division. Again, chances are you can probably do it. Okay. 13, we didn't talk about powers of powers yet. Again, chances are you might be able to do it. But 14, we did that. All right. 15, we did that one. Negative exponent. 11, or 16, no. 17, no. 18, no. 19, no. 20. Oh, there's a multiplication problem. I should be able to do that. Okay. So on 11 through 20, there's some that you guys should be able to do for sure. And then we'll talk about the other ones. But really, you could try all of them and see what's working up there, what's not. Come back on Thursday with questions. Okay. But I want you guys to at least try, the 4 or 5 there that you should be able to do within 11 through 20. All the other ones should be done by the time you walk into class on Thursday. So that on Thursday you can get your questions answered, get that wrapped up, get turned in. A lot of you have other stuff you guys haven't done at all. So many missing assignments in the grade book. Okay. So just where you guys should be headed. Okay. Again, if you have not taken that quiz from last Thursday, you really need to do that. We'll have the time set aside for that tomorrow. And then